Good afternoon, everybody. My name is Danny Plogger, and I am the Executive Director of the Virginia Transit Association. I want to welcome everybody to our fifth VTA and DRPT joint Lunch and Learn virtual webinar series. VTA is incredibly excited about this partnership and the opportunity to offer our members in the Commonwealth's transit community a deeper dive into the planning, challenges, issues, and processes with insights from the experts at DRPT. This webinar series would not be possible without the support, partnership, and expertise of DRPT, especially Alan and Bethel. Today's program is going over LEED certification and value engineering. As a reminder, our former programs are on VTA's YouTube page if you would like to go back and review them. As always, if you have any questions during the presentation, please put them in the Q&A box and I'll ask them at the appropriate time. Now, this afternoon, I have the pleasure of introducing our partners in this webinar series and today's presenters. Bethel and Alan are from DRPT, and we have a special guest, Josh, with Greater Lynchburg Transit. Bethel supports Northern Virginia's transit, DRPT's Northern Virginia office in Alexandria. She's a graduate of the University of Virginia and is a licensed professional engineer in the Commonwealth. She began her career at VDOT and joined DRPT in 2022. Alan manages DRPT's statewide engineering program and is based here in Richmond. He graduated from VMI and has a 30-year career in both the public and private sectors. Prior to joining DRPT, Alan also worked at VDOT, rising to the role of Louisa Residency Engineering. Our special guest today is Josh, who has been general manager of the Greater Lynchburg Transit Company since December of 2021. He started in transit at the University of Georgia in 2005, before coming to GLTC for the first time in 2010 as their assistant GM. In 2013, Josh moved to CityLink in beautiful, but I hear cold Peoria, Illinois, and then returned to wonderful Virginia in 2016 as Deputy Executive Director of WADA in Williamsburg before being promoted to General Manager at GLTC in 2021. Josh is excited about several projects that GLTC staff have been working on for the last year and have either deployed or are finishing deployment, including new AVLs, mobile fare collection, microtransit, and some very mysterious new technologies that aren't quite ready to be revealed. So please grab your lunch, sit back, and enjoy a great program from our friends and partners, Alan, Bethel, and Josh. Alan, kicking it over to you.
Great, very good. Well, we have two good topics today, and Bethel is going to walk through LEED, and I'm going to walk through value engineering. We've received a lot of inquiries about these two topics, and we really wanted to note it up front that there is a lot of information that we're just going to scratch the surface of, and we are not LEED or SAVE International credentialed. I would like to be someday, and we've really enjoyed the research behind these two topics. If you do have follow-up questions that we can't hit today, we'll post them in the chat or check in with Danny, and we'll certainly follow up on them. But we appreciate everyone's participation today, and I'm going to pass the torch to Bethel.
All right. Good afternoon, everyone. So as far as LEED goes, the basics. LEED stands for Leadership in Energy and Environmental Design, and it's a building rating system that was established by the U.S. Green Building Council in 2000 to verify the green features and performance of buildings, and it also provides a framework for sustainable development, construction, operations, and maintenance. And the rating system is point-based, where projects are able to earn like one of 4 levels of LEED certification. There's certified, silver, gold, and platinum. And just based on the number of points that you accrue, you're able to fall into one of these certification levels. All right, next slide. So LEED certified projects, transit projects specifically, they really benefit people, our planet, and are profitable. And so we often get questions from project sponsors about attaining like LEED Gold or LEED certified, but our question is going to be what the goals are specifically for your project. There are a lot of benefits to LEED, but instead of focusing on, getting a plaque that you can put on your wall, we want to identify like which specific LEED elements are aligned with your goals and to help you achieve those goals. Because ultimately, just because a project meets a certain LEED certification doesn't mean that the facility is actually meeting the project sponsors' needs and goals. But if you use LEED as a framework to focus on the elements that will meet your goals, it can be really beneficial. So some examples are listed here of transit facility goals that are aligned with LEED. They include reducing water consumption, using less energy and natural resources, and reducing the overall impact of development on the local, regional, and global environment. And so by implementing LEED strategies, transit facilities can become more efficient, they can become cost-effective and sustainable with a significant positive impact on the economy and the environment, as well as the commuters' well-being and comfort. And so transit owners can use this to their advantage by engaging commuters on the importance of sustainability and use the opportunity to engage the public, and the opportunity the public transportation sector has in minimizing greenhouse gas emissions, especially since there's flexibility available within the LEED building and construction for transit facilities to meet these requirements. So they've got transit specific options, and they've got compliance paths that are available to help recognize the unique characteristics of transit projects. And so US DOT VTA, they encourage green building for transit facilities, and all of the related costs are eligible for project expenses. And then there's also language in the Code of Virginia that promotes green building principles. And then we've got several LEED certified projects in Virginia, including the one that we're going to highlight today with Josh. Next slide, please. Thanks. So LEED certification is comprised of achieving all the LEED prerequisites and achieving a minimum LEED performance score of 40, and then on a scale of 1 to 110. And so the project information is reviewed by the Green Business Certification Inc. before LEED certification is awarded, and then the certification levels are defined as 80 plus being platinum, 60 plus gold, 50 plus silver, and 40 plus is certified. So these are a couple of the credit categories that apply to transit facilities. And so within location and transportation, there's a credit called intermodal connectivity and placemaking, and that encourages stations to incorporate intermodal connectivity features to improve mobility, including first and last mile transportation options. There's also a credit within location transportation that's called plan and design for resilience, which ensures that transit owners have resiliency and emergency preparedness plans for disasters. And then under sustainable sites, there's a credit called universal accessibility, which recognizes policies for safe and convenient accessibility for transit users. Under the energy and atmosphere category, there is a credit called Optimize Energy Performance, which includes several performance and prescriptive options for creating pathways of efficiency with equipment and systems in transit stations, like elevators, escalators, traction systems, things like that. And so there are a lot of different criteria that apply to transit facilities, and they're available for you to take advantage of them. And so if this is very high level overview, but if you want more information, the USGBC defines each of the criteria and all the available eligible points that are for you to in great detail on their website. All right, next slide. So these are just a few LEED solutions that are available, and I can just read them. They're on-site stormwater collection and treatment. These are things that transit agencies are already doing or can do that benefit the facility, the project, meet your goals and needs that you can utilize LEED for. So gray water reclamation, that's water waste from washing buses, rooftop photovoltaic panels that you can put on the top of your bus parking pavilions. Maintenance facilities can include a well-insulated, like cool roof, underfloor heating, ventilation, recycled materials, native plant landscaping to reduce water consumption, water efficient plumbing fixtures, but et cetera, et cetera. These are all things that you can incorporate within your project to meet your goals and also get LEED certification. Next slide. All right. Josh can, if you can share what your experience has been down in Lynchburg with LEED and the facility that you have maintained, any benefits that you've seen from it, any lessons learned, things that you can pass on to us as tips from your experience.
Thanks. And Danny, thanks for finding an ancient enough picture where I still have a head of hair on there. So props to that. But one of the biggest things that we've experienced with LEED is everybody kind of thinks that it's all this extra stuff. It has to be really fancy, but it can be pretty simple. The building that you see here is our transit center. It's LEED Platinum, but it's got a couple of features that really helped us to get there to that platinum. It's got photovoltaic roofs. It's got a green roof on a section. Those are kind of the expensive pieces. Looking here up under this canopy, going into our main waiting room, those windows are actually garage doors. So they can actually be opened for multiple reasons. One, our staff opens them sometimes when the weather's nice just to get fresh air. But also in the event of a long-term power outage, that allows for a minimal generator on site to run the critical areas and HVAC for the server room and the staff areas, but allow the waiting room to be passively cooled. So that adds a big impact there. We channel the runoff from the buildings into catch basins and then water plants with those. At the time, that was something that was good for LEED. But since then, the city has passed a stormwater fee that taxes the stormwater runoff on impervious surfaces. So all of those areas that we've covered with the roofing that is draining, all of that then doesn't count. So we're actually saving about $400 a month in stormwater fees, just simply because we are not having to process that. Same thing with impervious parking lots. Our operations facility has one. Now there's some stuff you have to do long term. We have to clean them and stuff, but that allows us to take a pretty good chunk of parking space and not have to be charged on having the impervious stormwater surface. Now, other things, when you start getting into smart ventilation systems where when you open a window and it turns off the ventilation in the office to keep you from trying to heat and cool the outdoors, those are nice. But that does require a little bit more maintenance longer term. So that's something that you just need to be cognizant of when you're designing these systems. The same thing with the underfloor heating. There are multiple ways to do that, but just bear in mind that if you're building a new building, you're going to have to be in it for at least 40 years. So you also need to think about long-term repairs and what you're going to do if, say, you're using the hot water loop heating system. If one of those pipes breaks underneath or one of them clogs up, are you going to have to dig up the concrete in your shop to get to it? Now, if it's other areas, you could use things like the rubber mats up underneath tile. That's a lot easier to fix, but you're not going to be able to drive a bus on that. So generally there's a lot of options for reaching LEED certification, and a lot of them aren't as hard as most people think. The location is a big piece. Is it, multimodal? Is it in an area that is conducive for people to walk? Well, most of the times when we cite transit centers, particularly, they already tick those boxes off. So that already gives you a kind of a leg up over somebody building a facility somewhere else. And then finally, kind of going in with LEED, but also a little bit with the value engineering piece. Really kind of think about what your future use for the building is going to be, particularly for maintenance and operations buildings. You want to think, well, we're using it for this right now, but in 20 years, are we going to have more staff? Are we going to need to do something different? Is there going to be a new type of energy source we're using? Electric's a big one, but if you're doing something with CNG or hydrogen, those have some very specific requirements for building buildings that it's much easier to do on the front end. And a lot of those requirements will also help you meet LEED. But thinking about all of that, making the buildings energy efficient, the more energy efficient you can make the building now, the better it's going to be for you in the long term, because that is savings for electricity, water, natural gas for heating, and all of that just simply is something saved for the long term. The other thing is, one last bit to remember when you're adding in, designing on the building, always know that things are going to change. You might not have designed in a place for a sink or wash up space, but then a couple years from now, things change. You might want to put a slushing machine in there. So, but thanks, Bethel and Alan.
Well, Josh, thank you very much. And we do really appreciate your perspective at firsthand. Now, I did have a couple of questions about when Lynchburg isn't as rural as some of the other smaller communities across Virginia, but the LEED buildings have some unique facets that not all buildings have, and especially yours there. Have you had any trouble finding services, support services, subcontractors, pieces, parts for your LEED elements over time? Has that been an issue, or has it been just pretty run of the mill?
So actually, we have not had issues for the LEED elements. It has been the more standard stuff, just regular plumbing, regular HVAC. The LEED elements have actually not been problematic. Now, going back into that, there's things that you need to do on a routine basis to keep things running smoothly. When I'm talking about our canopies that drain and run down to the basins, every couple of years, you just need to have those drains, basically cleaned and roto-rooted. The mulch that's in the basins floats, and over years, little bits get into the drains and they kind of stop up. That's just something that you have to do every couple of years. But so there is maintenance on it, but we've not really experienced anything major on the LEED components.
Hey, pretty good.
And there's also some stuff you can do. A lot of the power companies, AEP, Dominion, have programs where you can actually work with them to either convert existing facilities, and they'll give you a good chunk of money for that, for converting lighting to LED lighting and other stuff if you're just rehabbing. But also sometimes they'll partner with you and they'll install, say, the photovoltaics, and they'll be responsible for servicing them, taking care of them. You're just basically giving them a spot, and then they cut a piece off of your bill. So there's a way to shift some of that as well.
Wow, that's great. Some of the LEED facilities across the state, the transit facilities, have really, some unique elements in their HVAC systems. And I was initially concerned that those too may cause maintenance issues over time because they were unique. And I haven't gotten really any negative feedback about those as well. They're energy saving, they're easy to maintain. So some of those concerns have been belated by you folks out there.
Yeah, like I said, it's actually the standard HVAC stuff that you would have regardless. The filters need changing. Can't find this filter right now. That type of stuff.
Got it. Well, Josh, thank you again. We certainly wanted your perspective from the LEED side of the transit agency in our presentation. But as we dive into value engineering, you've had several transit construction projects under your belt. Mm-hmm. If you want to jump in at the end of my little segment on value engineering, please do.
All right, I will. Thank you.
Great. And with that, Danny, we will jump on to value engineering. Oh, wait, let me include this. We have some resources here. There's some links, and we can share the actual URLs for you. I had several links in the presentation out to some of the resources. And we also had some special things. I had some architects that we caught up with WSP and STV last week. And in the coming weeks up to this presentation, Gideon Sisman, Ryan Alpin, Laura Jeffords, and Narendra Prajata, all four of them provided some great insights and into our research, all LEED experts. And one thing that I do want to highlight again, the VTA membership includes some really great subject matter experts out there for LEED and value engineering. Please check in with Danny. Both of these topics are very expansive and there's a lot to them. So please check in with Danny and he'll help you align you with a resource if you have any additional questions, and you can certainly follow up with Bethel and me. All right, Danny, thank you. So we'll dive into value engineering. All right, value engineering. And value engineering is, there's this perception that value engineering is an exercise to save money, to reduce cost, to lower project cost. And if it is one thing that I do want to dispel during this segment of the presentation, is that it's not the goal. Value engineering is really to add value, to look at every facet of your project and determine how does this element of our project help us achieve our goal. And if you have to ask yourself, how does it help us achieve our goal, then that might be something that you would evaluate in a value engineering study. So what I'm going to do today is we're going to walk through just some fundamentals for value engineering and a value engineering workshop, the steps that are involved. So value engineering it's a systematic process. It's well documented. It's a set of disciplined procedures used to design and seek an optimum value for both the initial and long-term investment that you're making in your transit facility. It was first utilized in the manufacturing industry during World War II, and it's been widely used in the construction industry for many, many years. It is not a designer peer review or a cost-cutting exercise. When you go through and do a VE, it's really an organized effort to force you, the project sponsor, to really think through, what are my goals and needs for this project? What are the requirements? What are the functional requirements of your project, so that you can focus on the essential functions, and then within those essential functions, try to achieve the lowest total cost, including life cycle and long-term cost for your project. It's really an investigation. It takes a lot of time. And the value engineering exercises that I've been involved with over time for both transportation and transit projects, I've been very grateful for the amount of time that the SAVE International credentialed VE specialist has invested in the team and the effort. Sometimes it's really hard when you're starting with a bare bones project, trying to align the functional requirements with what the solution is providing and looking for ways to shave cost, but they always do a really good job. I did note SAVE, the Society of American Value Engineers. It was formed in 1959 as a professional society dedicated to the advancement of VE, through a better understanding of principles, methods, and concepts involved. Now known as SAVE International, and I'll reference that several times during the presentation. There are over 350 active certified value specialists in the U.S., and the requirements for certified value specialists developed by SAVE were at the request of the U.S. General Services Administration in the early 70s. So both U.S. GSA and SAVE, they have a wealth of information on value engineering, sample value engineering workshops, value engineering practices, cost, templates for requesting RFPs for professional services for VEs. So it really, the two of them have a lot of information that they can share. And the VE can be applied really at any point of a project. It even comes in construction if there's a change order. Optimally, the earlier it's applied, the better. And that will provide more really return on your investment during the design phase. And you won't have to do a lot of rework the earlier in the design that you are. If you do a VE at 100% plans and you identify an opportunity to add value to the project, that equals a change. And you're going to have to do rework, which typically equals errors and omissions. It's always easy to miss something in a full set of plans when you start making changes at the end of the design. We have both state and federal funded transit projects across the state. So I do reference, because the FTA provides a great value engineering framework and a lot of resources out there. So I do pull in FTA references during this segment of the presentation. I also appreciate that many of your projects are state funded, and it's not requirements, so they're the same, but the language is the same. So FTA really defines value engineering as an organized effort to analyze the function of systems, equipment, facilities, procedures, and supplies by a multidisciplinary group for the purpose of achieving the required function at the lowest cost. So today I'm going to go over a few more objectives, and then we'll walk through a basic VE workshop. So Danny, next slide. When we get into the first phase, the first step of a value engineering workshop, the key objective is to really think about your functional requirements for the facility. What am I trying to do? What do I need to do with this facility? To satisfy the required function at the lowest total cost over the life of a project, which for FTA funded projects, that's 40 years. So you really have to put your hats on and thinking caps on and think about the future, not just construction. To add unexpected function and efficiencies that may not have been thought about during the preliminary engineering and conceptual design and feasibility for the project. You bring on a VE team with a different set of eyes. They too have their own experts that they're going to engage to evaluate your functions and your solution that you're proposing and look for opportunity. Again, the goal is not to cut cost. The goal is to add value. So who is on, I mentioned the VE team, who is on the VE team? And that is a multidisciplinary team. It depends on the project. It's typically led by a certified value specialist certified by SAVE International. The project sponsor is included, the design team is included, and based on the scope of work, the VE team leader will bring in subject matter experts to evaluate the functional requirements from the project sponsor and then look for opportunities to add value. All right, Danny, next slide. Let me see, what is value? So value really is, it's personal. Value means something different to each of us. But when it comes to thinking about value engineering on a construction project, we really can think about performance over cost, whether that is performance of a pavement and its life cycle and how often it needs to be repaired or replaced, the performance of an HVAC system relative to its initial cost and its maintenance cost over time, the performance of a canopy over a rider waiting area and the elements of that canopy. And can it be simplified? Can it be a bus shelter? Or if it is indeed a canopy, is there a way to reduce its construction so over the life of that canopy over the rider area, it will have the least maintenance cost? So it really is thinking about performance over cost, function over resource. And it is unique to the project and the personal perspective of those who are developing and maintaining that facility. And I look back over some of our value engineering recommendations and studies, and some elements of adding value are as simple as, during the design phase, simplifying the building shape. Looking across the roof line, how can I maintain this over time? Where is water going to collect and debris? Where is it going to stack up? What am I going to have to repaint? Simplifying the building shape can add value and still meet your functional requirements over the life of the building. Thinking about, we mentioned the canopies. Replacing a canopy with a bus shelter is one way that you could add value to the project and still meet a functional requirement. But if you do have a canopy, thinking about the life cycle costs of that canopy, how difficult it is to construct, what does the foundation look like? Can it be on a slab foundation, or can it have its own foundation or deeper foundation that may cost less but provide the same function? Replacing concrete benches with metal benches. I know that seems pretty simple, but it has the same functional requirement and adds value to the project. Under some of the decking outside of the canopies, removing some of the acoustical elements, which are very expensive and difficult to maintain over time. They deteriorate and the birds pick at them. Maybe you can remove that. You still have the functional requirement of providing a canopy, but you've made it cheaper. Utilizing batteries for emergency lighting in lieu of an emergency generator. Many of you need emergency generators for far more than lights, whether you have your connectivity, your management systems, and so on. But if you do just have a situation where you've got lights, maybe batteries will be able to make up the gap until the power comes back on. Thinking about your HVAC systems and windows, aligning the building so that it gets heat in the morning and it's cool in the afternoon. Evaluating floor finishes. You can have very elaborate floor finishes that might not be as durable over time for the use that's going to be applied for it. High efficiency heat pumps and water heaters. Some of those things have a higher initial upfront cost, but are going to save you money over time. Even simple things like a tankless water heater at the point, instead of having a large water heater that just keeps water hot all the time. It's a lot of things like that you can think about in a transit facility. One that we've seen come up too very frequently are the different pavements. You have a broad range of vehicles that use your facility, from a very light passenger vehicle to a body on chassis transit vehicle to a large motor coach potentially. And the pavement depths and solutions for those different facilities can vary. You don't need a 9 or a 12-inch deep pavement section for a passenger parking lot. So varying the pavement sections and looking for opportunities to meet the functional requirements of the pavement in the areas where it's needed, and not having full depth pavement across the entire facility, that too is an opportunity to add value. So those were some of the examples that I've had that apply to many of our projects. All right, Danny, next slide. Some of the key questions when you are really thinking about value engineering is, what is the project? And what is my project going to do? And there may be different elements of that where you break it down from a passenger area to an employee area to my operators are going to be in this area. There's a maintenance area. What is this project going to do? And then what must it do? If we have an area to wait for for the riders to wait, does it have to have heating, cool? Does it need to have conditioned air? And so on. What must it do? What is its functional requirement? And what is a want versus a need? And then how much does that cost? Not just up front, but over the life cycle of the project and the facility. And what else may be able to do that job? And what does that alternative cost? It's not a cost-cutting exercise. There may be many circumstances when you go through a VE workshop, your cost may not go down at all. You may identify things that have a much cheaper life cycle cost that cost you more upfront. So if it does have an alternate cost, what is the life cycle cost of each of those elements? And who's going to maintain them? And how much does that cost? So lots of things to consider there. All right, Danny. I did want to go in again, what VE is not. As an engineer, I design a project based on a set of requirements, my perspective, my engineering experience, and the needs of the client that I'm servicing, my customer. It may, just because I'm an engineer designing a solution, it doesn't mean that I am thinking about value engineering from inception. It's not designed into the project. I do get feedback that, well, we think about VE from the very beginning. And we all do. We're not going to gold plate a project unnecessarily and add cost to a project. But a SAVE certified value engineering specialist is really going to think with a different set of eyes and teams on how you can achieve the best value on a project. It's not an exercise to forfeit essential functions to reduce cost. It simply isn't. Value engineering, the goal of value engineering is to add value. It's not to reduce cost. It's not an opportunity to critique the design. It is very easy to fall prey during a workshop as the engineer to be a little sensitive to someone else proposing changes, different types of materials, different configurations for loads, or it's easy for us to fall prey to that. But the value engineering exercise is not an opportunity to critique the design. It's a team of specialists that comes in, and I've been grateful in every instance in how they tiptoe around the architect or the engineer's design because they don't want to offend them. You got a great design here, but we as the VE team have an idea to add value to the project. And that's a tightrope to walk, and they do a good job with it. VE simply answers the question, does the current design best accomplish the goals of the project? And while I'm on this slide, Danny, I know not all of our projects are FTA funded, but FTA has a great reference document. They have the Oversight Procedure 30, Value Engineering and Constructability Review. And that document includes a couple of highlights that I'm going to go over. It's focused on a major capital project, and it requires VE on every major capital project. Now, for FTA, that's over $100 million. But it does encourage value engineering on all construction projects, and we at DRPT do as well. Value engineering has a place during the design and for change orders during construction on every project. It doesn't matter what the cost is, but the FTA on major capital projects requires it on all of them. VE should be performed early in the design process before you make major decisions. We have had some projects where value engineering is done very late in the project design, and it's required changes, extensive changes to the design that may change the foundations, the electrical systems, all of the mechanical elements, and so on. And that's very expensive, and there is a lot of opportunity late in the design phase for errors and omissions. So it's much better to do it as soon as possible, but better late than never. For design build, we're seeing more transit facility projects go in design build. It's critical that the VE is done prior to the release of the RFP for the design builder. The design builder needs a set of assumptions in order to provide a best cost and then complete the design and build the project using their own efficiencies and means and methods and efficiencies and least cost. The VE needs to be done before you go out with your design build RFP. A well-conducted VE study, according to the FTA, should generally return $20 in savings for every dollar invested in the study. And I thought I haven't gone back and looked at the studies we've had to see if that metric works out, but it was really interesting that they noted a return in the study and showing the value of it. We did note that the VE team leader is a certified value specialist certified by SAVE International, and they do provide a job plan framework that is used across the world. Okay, Danny, next slide. So the basic workshop. The value engineering workshop, you get started. The first step is to really understand the project. Your VE team focuses on what are the functions, what is required, what are your goals. Then the next step is the group brainstorms ideas for alternate designs. And it can be, this is a brainstorming session. It's open, it's a no judgment zone. It's really any idea that you can spitball that supports the functional requirements of the project and adds value. Any change. It's not just LED incandescent light bulbs or batteries versus generators or this type of EV charger versus the other, a different type of pavement. It is anything that you can brainstorm together to think of that adds value to the project. The next step, the VE team will begin to bring in their subject matter experts, architects, structural engineers, acoustic engineers, bring them in and really begin to work through all of the ideas from the brainstorming session and identify those that may genuinely and practically provide value of the project. They'll then go on with each of those that they've identified and prepare an independent proposal for each viable idea. And on large projects, the VE team will go as far as to design structural elements. They will look at other aesthetic treatments on facades. They will look at rain garden solutions. They will go into a great deal of detail and almost independently design another solution just to ensure that the idea is practical. Then the last step, The value engineering team, led by the SAVE certified specialist, will prepare a report and present those findings back to you, the project sponsor. The project sponsor will then make determination as to what value engineering elements they want to advance and which they do not. And then from there, the final report is generated. It's passed to the project designer, and the architect engineering team then takes the marching orders and finishes the design. All right, Danny. So the next slide, here we go. The 5 steps. You have an information phase, you have your creative phase, you have your evaluation phase, your development phase, and then the presentation phase. The methodology in these 5 steps at the beginning of the VE study, it's really important to understand the background and decisions that have influenced the development of the design to the point that it's at. And it's from what Bethel and I have observed, since we've started at DRPT, it's very dynamic. You may start at one transit agency and perform a feasibility study that then gets passed to another to advance into preliminary engineering and VE that then gets passed to another to ultimately build. And the resources across the life cycle of a project in development and delivery change. So making sure up front that when you begin your VE, the funding and the feasibility for your project may have been performed 6 years ago. Understanding and having that documentation with you about what were the requirements at the time when the feasibility study was conducted and when the funding was applied for, what were their needs then, and make sure that you collect as much information as possible, analyze those key functional requirements and any functions that your locality may require of you, procedures, maintenance procedures, available solutions to maintain the facility over time, really doing a lot of research up front. And the FTA and your SAVE specialist will have a template, a checklist, and provide you with a list of everything that you should review or provide to them at the onset. After you've evaluated all of those things, you've really taken a deep dive and thought about what are my requirements for this project, documented your functional requirements, and all as the project sponsor agreed to the functional requirements, then you can step into the creative phase. The speculative creative phase, it really involves listing ideas. It's a spitball session. You take a step back, the entire team thinks of as many ways as possible to provide the necessary required functions that the project sponsor has identified within the project areas at either a lesser initial cost or a cheaper life cycle cost, which represents improved value to the project sponsor. Judgment of any ideas at this stage is prohibited. Any idea matters and should be considered. The value engineering team is looking for quantity and association of ideas, which will be screened in the next step. So don't hold back. Many of the ideas brought forth in the creative phase are the result of work done in this phase 1 functional analysis. Step 3, evaluation phase. In this phase, the VE team, together with the project sponsor, defines the criteria that will be used, that they will all collectively use for the evaluation. And the SAVE certified team leader is not going to do that in a vacuum. They're going to work with the project sponsor to determine what's important to them. And then they're going to evaluate each of the ideas developed during the speculation phase in that manner. Analysis and evaluating ideas, really anything that's found to be impractical or not worry are discarded. There may be a great opportunity there, but the life cycle cost is too expensive. The upfront cost is too expensive. It's prohibited in some way. It may not meet Buy America requirements or FTA requirements and so on. It's just simply not a practical solution. That's discarded. And those ideas that represent the greatest potential for cost savings and value are developed further. And then a weighted evaluation is applied to account for impacts other than cost, such as schedule, aesthetics, the ability to maintain, who is going to be responsible for this over time. Then from the evaluation phase, we move to the development phase. Many of the ideas are expanded into workable. It really is, you shortlist your practical ideas into something that you can quantify and evaluate. And in the development phase, the VE team leader and their subject matter experts will go away. They will independently design canopy foundations. They'll bring in architects to evaluate different solutions for aesthetic treatments. They'll look at how much stormwater you're going to collect and need to treat. They will evaluate every single practical solution to ensure that it indeed is a permissible value-adding proposal for the project. They'll develop sketches, cost estimates, life cycle cost calculations, and then a brief narrative for each of them describing how the proposal was identified, the requirement in the project that it meets, the method that they use to evaluate, redesign, what have you, that idea, and then their recommendation and any upfront and life cycle costs associated with it. And that will be compiled into the next step, which is the presentation phase back to the project sponsor. The VE team leader will take all of those recommendations from their subject matter experts and present that back to the owner. The owner will then evaluate each element and make a determination as to what they're going to advance. And at that stage, after the VE team leader has made their presentation back to the project sponsor, they step away. They've done their job. Now they're available to answer any questions, to evaluate any of the ideas that you want to advance into final design further. They're there for you for that, but their job's done. Your job as the project sponsors to take this information and recommendations that they've given you. You make your decisions, you direct your design team accordingly. And they move on and design the facility accordingly. Okay, Dan, next slide. I'll go through this pretty quickly. Danny had just a quick overview of each step. The information phase, overview the projects, you review the plans, you hyper focus on the functional requirements, and you really take a deep dive to identify what those are. You identify the project cost and schedule that's shared with the group, and you also document all of these functional areas. Okay, Danny. Next slide. The functional requirements. I wanted to draw this out because it is the most important step of the value engineering study. And it is a great opportunity for those of you who wear many, many hats to focus on your facility project. It may have been a feasibility study that was done years ago, but now your design is advancing. You're involved in a VE study. And if anything, really taking a deep dive and appraising the functional requirements of your facility, what you need this to do for you, both today and 30 years from now, it really forces you to get engaged and to take a breather and really think about your project. Is it a transit hub? Is it a maintenance facility? Is it an administration facility? What does the next generation of our team look like for administering this transit agency? ADA compliance, boarding and alighting areas. If you do have those, you can take a deep dive to determine what type of vehicle do I have? Where are they going to come from? How long are they going to be here? How heavy are they? And really think about your vehicle. Durability, useful life, we consider 40 years. Illumination of pedestrian and areas. That's certainly very important, both from a security perspective and a safety perspective, and vice versa, safety and security. And that is a key functional requirement. Light vehicle parking. Do you have any light vehicles that are going to use your facility versus a transit vehicle? Are you going to include EV charging, either for your transit vehicle or for your parking? You really think about all of those functional requirements. Do I have operators that need to have a lounge here? Do they use the restroom? What type of maintenance do I do on my vehicles at this location? Do I have a contractor or do I use internal resources for that? So this part of the first step is the most important. It's the most important, and it's the most important part of VE. Okay, next slide. Creative phase, next step. It's brainstorming ideas, no judgment. Anyone, regardless of your background, you don't need to be an engineer or an architect. And the best ideas come from those who aren't tainted like we are by manuals and engineering guidelines and best practices that are in a book somewhere. We get a lot of great ideas from you who are going to use this facility. So don't hold back. This step is really critical to identify anything that can add value to your project. But it's also that one thing your VE team leader is going to continually do through the creative phase is remind you of those functional requirements that you've identified. All right, next slide. Evaluation phase. The VE team is going to step away. And this is when they do what they do. The VE team leader is going to bring in subject matter experts, whether they're architects, engineers, transit planners. They're going to bring in subject matter experts to evaluate every practical idea that you've come up with in the previous stage. They're going to rank them. Is it a major improvement, or does it detract from the value of your project? They're going to develop cost estimates, both initial, upfront, and life cycle. Looking at your initial cost, how much is it going to operate and maintain? And then if I have to replace it before its useful life, how much will that cost me? So in the evaluation phase, they're going to take a deep dive, and we've seen them redesign canopies, redesign foundations, redesign structural elements of facilities, look at where the sun is coming up, how much HVAC is needed, how much rainwater you're going to collect. They really do a great job and take a deep dive in evaluating each of the ideas that you've come up with in the creative phase. Okay, Danny? And then development, they'll take each of the practical recommendations, they'll provide recommendations and prepare to present that back to the project sponsor, and they'll translate it. They'll really look at, with my target audience, how do we communicate this in a way that they'll understand what it is we're recommending and what we've evaluated to get to this recommendation. All right, next step. Presentation phase is when the VE team will come in, they'll present their findings and recommendations. They'll answer any questions that you may have. They continually force you in every instance for you to go back to step one and really think about what are your functional requirements. They then can answer any questions about the design elements that they provided. They can give criteria back to the project's engineer and architect for the solution that they're proposing and how to incorporate it back into the design, and they step away. And it's up to you, the project sponsor, to then digest everything that they've told you, agree to what you're going to change and what you're not, document that, especially if you're on an FTA project, give those marching orders to your architect engineer, and then they can begin the remainder of the design. Post-workshop as a practice, Danny, next slide. I wanted to include a slide in here for post-workshop activities. Documenting, again, you may work at one transit agency today and quickly be promoted to another tomorrow, and your successor is going to need to carry the torch forward and finish the design and move the facility into construction. So you don't want somebody to come in and Monday morning quarterback everything that you've just done in your VE. So making sure that this information lives somewhere, whether the functional requirements that you've identified, all of the documentation that you've developed to prepare for your study, the recommendations of the study, the final VE report, that needs to live somewhere where it can be accessed over time. And if you have a new project manager who comes in for the transit agency 4 years into the project, it's very easy to take a step back and say, well, why are we doing this? Why are we doing that? Who made that decision? And making sure in the post-workshop activities that all of your decisions and the information that you used and compiled for your VE study are accessible somewhere. The FTA, your regional representative, will require you to provide that information to them along with your recommendations. But make sure that it lives somewhere and that you're not scouring for that information that's done a couple of generations back. And with that, I also included some resources and some URLs in here back to USGSA, the Federal Transit Administration, their Oversight Procedure 30. The Code of Virginia does require the use of value engineering on certain projects, and certainly a link back to SAVE International. So if y'all have any questions about that, thank you for at least the VE portions. And Josh, I'll take a minute while we have you. Any feedback on value engineering and experiences that you may have had on your projects?
So value engineering's a good piece. I think one thing to really take out of it is what you were talking about, Alan, where if you have a very firm idea of what this project is going to be, the better idea you have of this project going in, that actually makes the value engineering process much easier. If you just say, hey, we want the greatest transit center in the world, that's a huge open-ended question. But if you say, hey, we want one that does this, and this, we want an indoor waiting area that's climate controlled for our customers. We want to have a small meeting room. We want to have a space for our operators. We want a customer service desk. All of that makes the design easier, but then also makes the VE come back in easier. If you say, hey, this facility doesn't matter if it's powered or not, in the event of a long-term power outage, that's something that's addressable. So that would be my suggestion is really kind of focus on what you want the facilities to do and have that as a goal, even before you get into value engineering. The other thing is, I think, just to reiterate your point, most people think value engineering means to make it cheaper on the front end, but that may not necessarily be the case. But you just want to be able to articulate why you're picking the option you are, because it may be more expensive now, but will save you money, later on down the road. The one thing that's never going to go away is the operational cost for heating, cooling, water. I mean, those things have just continued to go up from the past. So the more you can save on those, the better you are.
Got it.
And Alan, if I wanted to add another piece for anybody that maybe isn't getting involved with FTA money or is just doing a smaller project, your group can also you and Bethel can help with some kind of smaller, in-depth value engineering and stuff, at least looking over plans and making some recommendations as well, correct?
That is correct. And I appreciate the plug, Josh. I do. And we had a VE study that we facilitated for a project that CSPDC has. And I tell you, Ann Cundy and her team, they did a great job, along with Kimley Horn, it's a smaller project, it's a transit hub. But they evaluated, they took a really deep dive and focused on what are our requirements for this project. And they spent a couple of hours just talking about functional requirements. And then the next step, really thinking about ideas to add value. And I was really grateful for the opportunity, and FTA or not, we really do encourage VE on any project, and Bethel and I will certainly facilitate that. So Josh, thank you. I appreciate that. It's a good plug. We do. And some of the life cycle costs that you talk about, there was another facility, they were collecting their gray water and their rainwater, and somehow that was used if needed for their geothermal HVAC system, and it required certain levels of filtration. And all of those things in the end turned out to be pretty low cost maintenance items that haven't required a lot of their attention. They may have had a little apprehension early on to think about another solution, but doing your research and having your VE team there to help you, don't shy away from something that over time may be a good opportunity to add value to your project. And certainly your facility in Lynchburg's got a lot of really neat elements that could have caused a manager during the design phase some concern about what in the world am I going to do in collecting this water with these solar panels and so on. But I'm glad that the GLTC took the plunge, and now you've got a cheaper facility to maintain over time as a result. And so we'll wrap up. Josh, Bethel, Danny, thank you very much for this opportunity to go through these two topics. I hope it generated some thought within the group and the audience. We certainly get a lot of inquiries about it and look forward to any questions that your membership may have for us. And Danny, they can funnel those back through you and send them to us, and we'll broadcast them any way that we can.
Absolutely. And thank you again, Alan and Bethel and Josh, and for everybody for joining us today. We will share Alan and Bethel's emails. And thank you for this wonderful presentation. It will be put online on YouTube sometime early next week if you want to go back over it. And we look forward to seeing everybody again in December for our next Lunch and Learn. Thank you.
Thank you, Danny. Thank you all very much.